I'm going to begin by talking about patches and updates. Today's modern operating systems are very complex and are composed of tens of millions of lines of code. Even your network devices and appliances are very complex and have complex software packages and configurations. This complexity of the modern operating system has led to the necessity for updates, patches, and hotfixes. These are used to add features, fix bugs, and repair security holes as they become known. One goal of administrators is to keep systems as up-to-date as possible through the use of these updates, patches, and hotfixes, reducing the system's vulnerability and increasing its functionality while reducing maintenance costs. A patch is a small section of code that is used to either increase functionality or fix a problem within a software package. A patch will change the version of the software package in a minor manner, as in version 1.0.0 will become version 1.0.1. An update is a larger section of code that is used to either increase functionality or fix problems within a software package that become known after production. An update will change the version of the software in a more major manner, as in version 1.0.0 will become version 2.0.0. Or, using a Microsoft example, Windows 8.0 became Windows 8.1. A hotfix, which can also be called a vulnerability patch, is similar to a patch, but it is actually smaller than a patch. They are designed to be deployed to fix a very specific issue within an operating system or other software package. Hotfixes are usually issued to fix security problems that become discovered after the software package has been produced. A service pack is a cumulative Windows update package that contains all patches, updates, and hotfixes between 2 points of time. Microsoft releases service packs as a method of easing the installation of an operating system, helping to keep it current. You install the operating system and then you install the service pack. That way you don't have to download and install every patch, update, and hotfix. In most cases, it is possible to automate the patch and update process through registering the product with the vendor who created it. Microsoft's operating systems can be set to automatically check for updates, and it will download and install them if you configure it that way. Most hardware vendors offer the same type of service for firmware and drivers. In most cases, these services can also be set to just inform the system of the availability of patches and updates, allowing administrators to manually download and install them. In a production setting, all patches and updates should be installed and tested in isolation, as in on a test system in a testing lab, before they are installed on vital production equipment. This reduces the chances that a patch or update will bring down a system that is functioning all right, but is in need of the patch or update. Now let's discuss upgrading versus downgrading. Quite often, it is highly desirable to install the latest patches and updates in order to keep systems running efficiently. However, sometimes issues arise with the installation of a patch or update, leading to problems that were not caught during the testing phase. This is where backups and downgrading come into play. Backup copies of all systems and configuration files should be maintained in order to downgrade or roll back to the previous version for when a problem occurs during the deployment of a patch or upgrade. Being able to roll back to a prior version is often easier and more efficient than trying to resolve a problem that was introduced with an update. Administrators should keep backup copies that include the base package of the operating system or software package, a backup of the system before the patch was installed, and a backup of the system after the patch was installed. All of these backups should be kept and maintained as per your organization's policy.